I always feel like it's important to start by lowering expectations. You did the opposite. What the hell? Okay. So I also have to confess that when they asked me for a title, this just kind of popped into my head, and I had no idea what the content was that went with it. And then they came up with this very nice poster, which I was very impressed with, and now I feel like I have to come up with some content worthy of the title of the poster and the introduction now too. So we'll see if I succeed. I'm not optimistic, but we'll see. Anyway, so let's start with a couple of good quotes about economic theory. Here's one from Joan Robinson. Pure theorists sometimes prefer a theory that is so pure as to be uncontaminated with any material content. It's a bit harsh. Then we get one from a Nobel Prize winner, Leontia, who describes her experience with theoretical economics, I suspect. Page after page of professional economics journals are filled with mathematical formulas, leading the reader from sets of more or less plausible but entirely arbitrary assumptions to precisely stated but irrelevant theoretical conclusions. Nobel Prize winner, he's not supposed to be like that, but it's kind of mean. And then we get a great philosopher, Ronald Reagan, who once said, an economist is someone who sees something that works in practice and wonders if it would work in theory. And I find it personally deeply ironic that of these three quotes, one of them gets it right, and it's the non-economist who I agree with on practically nothing else. Other than outline. I should say, actually, I remembered this quote and then Googled it to try to find the exact phrasing and discovered that a lot of other people said similar things before Reagan. So I think he stole the line. So, but anyway. But I think Reagan's line is exactly correct about how theory often does work and really how it should work. So let me try to clarify. Okay. You see it says here, in my view, almost everything I say should be prefaced with that. But if I said that every time, the talk would take too long. So just keep in mind that even though that's unstated, it's there. Okay. In my view, economic theory has nothing to do with figuring out what facts are true in the world. That's why we have empirical work. They go and figure out facts, and when they figure out facts and they bring them to us, like facts like, hey, this thing works in practice, whatever the thing was that Reagan was talking about there, then, as theorists, depending on what the fact is that they're bringing to our attention, we may want to say, that's kind of interesting, and to try to think about that from a theoretical point of view, to try to understand how does that fit with the theory that we think about. But not always, not always. The thing I want to stress is that the relationship between economic theory and reality is, let's say, tenuous. I had a hard time thinking of a one-word thing to put there, and tenuous was the best word I could come up with. So what I want to try to do in this time, in this talk, is to explain how I think about the relationship between economic theory and reality, and some implications that I think that has. For how we should think about what theory does for us. Okay, so let me start with an example. I've written a bunch of papers. Every paper I've written says, okay, assume that agents have utility functions and do this, that, and the other. Nobody has a utility function. No sensible person has a utility function. And I will prove that. This is a beer. Some of you may recognize it. This is Sam Adams. It's a bit blurry. It's a Sam Adams. Okay. And so don't let the blurriness throw you off. That leads to too many jokes. I guess if you've had enough of them, they start to look blurry. I don't know. Anyway, so there's a beer. So now here's another beer. The way I got this second beer is I want you to assume that what I did was I took this one and I removed a single drop of liquid and replaced it with a drop of water. Okay, so that's what this beer is. Okay. Now, I claim that any sensible person who actually has a utility function, I'm going to argue there can't be such a person, but if a sensible person had a utility function, they would have to have the same utility from these two. Because there's no way they could distinguish them. right? If I offered them, try this one, try that one, there's no way they could possibly distinguish them. So if a sensible person had a utility function, they'd have to get the same utility from both. Okay. So now let's do it again. So the third beer I get by taking a drop from liquid from this one and replacing it with a drop of water. So now again, if this hypothetical sensible person with a utility function were to evaluate these two beers, he would have to say that they have the same utility. And since these two have the same utility and these two have the same utility, these two have to have the same utility. But they've all got the same utility. Okay, well let's repeat that a few times, and a few more times, and a bunch more times, and eventually we get Bud Light, right? And so this argument that at each step you'd have to have the same utility says that you'd have to have the same utility from this initial Sam Adams as from the Bud Light, and no sensible person could have such a utility function. So clearly that's wrong. Okay, so what do we make of this? There's several responses we could have to this argument. Okay, one response, which I think is incorrect. So I'm going to give you two incorrect responses and then a correct one. So here's one response that I think is totally incorrect, which is to say, well, economic theory tells us that people have utility functions. Therefore, there's something wrong in the reasoning I just gave. People couldn't have that kind of behavior. Couldn't see these things as completely equivalent this way. I think that's just totally wrong. I don't want to argue that no one could ever distinguish the difference of the drop. That's maybe going a little too far. But I certainly think that a lot of people would exhibit that kind of behavior. That they would see each one in the sequence as totally the same as the one before it. So this, I think, is a ridiculous response. And I really like this quote from a mathematician who I know nothing about that I think expresses it very well. He says, in mathematics, names are free. It's perfectly allowable to call a self-adjoint operator, I don't know what it is, don't ask me, to call a self-adjoint operator an elephant and a spectral resolution a trunk. One can then prove a theorem whereby all elephants have trunks. I guess that means all self-adjoint operators have spectral resolution. But anyway, what is not allowable is to pretend that this result has anything to do with certain large gray animals. Okay, when we prove a theorem in economic theory, we're using a lot of words that we have intuitive ideas about. We like to use words like preference. People have preferences. I like chocolate better than vanilla. That's a preference. But because I'm calling it that, that doesn't mean that my preferences satisfy all these properties of this mathematical model. In fact, I seriously doubt they do. It would be kind of miraculous if real people were as simple as these mathematical objects in the model. Okay, so we shouldn't expect that the theorem that we prove ends up telling us something necessarily about reality, because the mathematical objects don't correspond so precisely to reality. Okay. Another incorrect response. Economists believe that people have utility functions, and hence economists are idiots. You see things like that a lot. I'm not saying no economists are idiots. There's a lot of economists out there. Let's not name names. But anyway, but certainly, and maybe the economists who have response number one would be idiots. I don't know. But this is clearly unfair. So, because I think economists understand, most economists at least, certainly economic theorists, there we go, understand that people don't have utility functions. So this is just unfair. So what's the correct response? So I think the correct response is this. People don't have utility functions, but, if it's useful for you, assume it. Go for it. So this, of course, begs the question, how can a theory that we know is false be useful? Right? How can it be that I can know in my heart and soul that people don't have utility functions and still, other than, maybe it's just because I want to publish papers, but I swear that's not the only reason. I think it actually can be useful. So why? Why is it that this false theory might be useful? So here's a great quote from Ronald Coase, another Nobel Prize winner. He says, a theory is not like an airline or bus schedule. He says timetable, but what the hell. We are not simply interested in the accuracy of its predictions. A theory also serves as a base for thinking. It helps us to understand what is going on by enabling us to organize our thoughts. Faced with a choice between a theory which predicts well but gives little insight and one which gives this insight but predicts badly, I would choose the latter. Okay, I think it's a great statement of what I'm trying to say. Let me try and expand a bit on that. Essentially, any broad general statement you might make, including the one I'm currently making, by being broad in general, is almost surely inaccurate. You know, there's very few. Reality is complicated, right? So if you make broad general statements, there's going to be exceptions. There's going to be things about it that aren't quite right. But I'm sure this comes as a great shock. Even economics professors have limited brains. Try to restrain your shock on that. So what that means is that if they want to think about things and they want to try to reason about what they think is going to happen and try to understand how things are happening, they have to work with principles that are too simple to be correct. Okay. So if you try to work with something that's more accurate and more detailed, you're just not going to get anywhere. Another way to say, so I'm very proud of this sentence. This is a sentence we wrote in a paper, and I just really like this sentence. All understanding is generated by deciding which aspects of reality to ignore. I firmly believe that. Because no two situations in the world are identical, right? If you read history and you're trying to learn from history, you think about what happened to you, when you were younger and try to learn from that. If learning requires you to pay attention to every single bloody detail, and you can only infer about other situations when they're exactly the same, you're toast. You're not going to get anywhere. If we can only learn from history when history exactly duplicates itself, we're in trouble. So you've got to decide what in those situations in the past was irrelevant. What am I going to ignore? And frankly, you're going to have to ignore more than just what's clearly irrelevant. You're going to have to ignore some things that are sort of more or less semi-irrelevant. Great quote from Stephen Wright that expresses as well. I have a full-size map of the world. At the bottom it says 1 inch equals 1 inch. I hardly ever unroll it. If we had an economic model that was a full-scale model of the economy, I guess $1 equals $1 or something, you couldn't unroll it. Right? You couldn't do anything with it because it would be too bloody complicated. So I think that's the point. One implication that I want to mention from this is because models are always false, we should not be surprised when they're refuted. So when somebody writes an empirical or experimental paper where they say, the model is false, we should say, yeah, okay, so what else is new? In fact, if the model isn't refuted, it's got to be because the data wasn't good enough. Okay? It's got to be that the data just didn't reveal the inaccuracies that we know that are there. Now, this is not to argue that empirical or experimental work is uninteresting. I definitely don't believe that. But what it is saying is that when we look at those results, we've got to think about, okay, what parts of the theory got refuted? If it's the parts that we knew were kind of oversimplified that we just stuck in there because it made it tractable, big deal. If it refutes something that we took more seriously, then that's informative. Okay. All right. So I'm probably hammering away at this point too long, but bottom line is the question shouldn't be, is the theory true? Because the answer is always no. The question should be, is the theory useful? So let's talk about how theories might be useful. I keep hammering away at this idea that they're going to be useful. We have to simplify to make them useful. So what are the uses? So the first is just creating a language. This is kind of the first step. It's important to keep in mind that it's a first step. We have to name all the relevant objects. We have to create a basic taxonomy, think about how things are related to one another. So a lot of what you probably did in your, in principles of economics, you probably spent a lot of time just learning terminology, and that's exactly this step of, setting the stage, so to speak. Again, it's important to keep in mind it's only a first step. So Alfred Marshall, who wrote one of the first economics textbooks, had this observation. I admit that these terms, utility and marginal product and so on, repel some readers. I guess this was the sociology majors. And fill others and fill others with the vain imagination that they have mastered difficult economics problems, when really they have done little more than learn the language in which parts of those problems can be expressed. Okay, or Gary Larson, I think, said it better. I like that word. Anyway, so that's so it's important use, but it's, it shouldn't be taken too seriously. Second, checking an intuition. So economists and even normal people look at the world and see things that interest them and intrigue them, and they kind of wonder, okay, why did that guy do that? What is this going to lead to? You know, and you get some intuitions. You say, I think this guy's doing this because he's going to do that, and this is going to lead to, you know, the collapse of the economy or what have you. So you form these hypotheses, these intuitive ideas. But intuitive reasoning is often wrong. It's really easy when you're just thinking about something casually to have this reasoning and have it just not be right. So you want to check it. How do you check it? You check it by making it really precise. And I'm not going to claim that mathematics is the only way to make something really precise, but it's the only way that I really know. So that's why it gets mathematical. Whether it has to always be as mathematical as it is, you know, if you tell me somebody made something more mathematical than it needed to be to make their point, I'm not necessarily going to argue with you. But it does have to be made mathematical in order to verify whether it's right. So I love this quote from Paul Krugman. This isn't something he wrote. I heard him say this in a podcast on a lecture. A lecture he was giving. He says, "What I did at the time, a very economist thing to do, was to build myself a little model to prove the point that I believed." I've now completely forgotten what the point was that he believed. But anyway, so I built a little intertemporal optimizing whatever. Well put. And to my shock, and this is the point, of course, of doing models, it actually gave me the opposite answer. So he realized, really two things came out of this. Number one, he realized that his intuition was wrong. And number two, he realized something else, which is you find unexpected results, and they tell you something. Right? Now he realized that his intuition was actually leading him to a very different kind of conclusion. And that was informative. That was news. So finding unexpected results can lead to new insights and new directions. So let me give another example of that. So auction theory. The earliest work on auctions considered what's called the independent private values model. So to explain this, let's think about an auction for, say, paintings, art paintings. And let's not think about investment. Let's think about just things that are going to go, you know, on your wall. So, you know, so I look at this painting and I say, you know, do I like it? Do I want to see that, you know, when I'm eating dinner? Assume I have a color scheme. Does it go with my color scheme? Like I told you, assumptions are not realistic, so it works. You know, and so I look at it and I just say, okay, this is worth $10 to me. And that fact doesn't tell me anything about what it's likely to be worth to anybody else. You know, and if this guy tells me it's worth $100 to him, that doesn't change the fact that it's worth $10 to me. Okay, may make me wonder about his taste in art, but that's another story. Okay, doesn't change my values. That's what independent private values are. Okay, so one of the first theorems in auction theory, which I think didn't Meyerson prove this? Meyerson have the first. Okay. Anyway, famous theorem in auction theory, revenue equivalence. So what the revenue equivalence theorem says is, in this setting, a very wide range of auctions give the seller the same expected revenue. So I'm going to give a very, very, very inaccurate, loose statement of what the class of auctions is we're talking about. Roughly speaking, every auction where people who have a higher value find it optimal to bid more, and where there's no entry fees or things like that, every auction with those properties is going to have the same revenue for the seller. That's really weird. And in particular, that seems surprising if we think, well, maybe this model might have some connection to reality. We know we don't expect it to be exactly true, but we might want it to have some connection. And in fact, if we look at the world, what we see is so the English auction is the one that that you would see on TV, where the auctioneer says, "Can I get $10?" and somebody says 10, and then somebody else says 11, 11, and so on and so forth, until the bidding stops and he sells it to the last person who bid. Right, so that's an English auction. It's extremely common. It's a lot more common than a lot of really screwball things that we could make up that, according to this theorem, would have the same expected revenue. But from the seller's point of view, would be identical. So why? Well, again, we know the theory isn't exactly true, so we're not surprised that it doesn't match reality. On the other hand, we might think about, okay, well, what are there factors things that we assumed that if we change them, get something closer to this? Okay, so it's giving us a new direction to think about. So in particular, this is one of the things that led to work on what are called common value auctions. So a common value auction is where, for example, think of an auction for drilling rights for oil on a particular piece of land. So we may not know how much oil is there, but there's a certain amount of oil there, and it's independent of who buys the drilling rights. So for all of us, the value is the same. So that's common values. And common value auctions turn out not to have this theorem true about them. And so that leads to, and they have a variety of interesting properties. So again, the bottom line is I'm not saying anything that this tells us something about reality necessarily, but it gives us some interesting intuitions and some interesting connections. Or, leading into the next thing, it gives us some intuition about how things might work. So, here I want to talk as an example about this paper. It's a lot of fun by Knowles, Persico, and Todd, called Racial Bias in Motor Vehicle Searches, Theory and Evidence. This was in the Journal of Political Economy in 2001. So, as a theorist, I shouldn't be talking about data, but I'm going to have to explain this, so it's unfortunate. Hopefully you can build. Anyway, so they start with an empirical observation. So I should set the stage here a bit. So the issue that they're looking at is policemen stopping motor vehicles on the highway and saying they have probable cause to search the vehicle, looking for, well, I'm going to focus on drugs. They could be looking for other things. But generally, they're looking for illegal drugs. Okay? And the empirical observation, so just focusing on males for a second, the empirical observation is that black and white drivers, compared back to black and white drivers, blacks are stopped much more often, at least in their data. But the rate at which they're found to be carrying drugs is essentially the same as for whites. Okay, so this was the subject of a big lawsuit, you might imagine, because the charge was that the police were being prejudiced. So one thing they did was say, okay, well, let's just think about that from a theoretical point of view. Let's just construct a little model and see what it predicts, and think about, if this were a true story of the world, what would be going on. So this is the most technical I'm going to get at this moment. So if you haven't done game theory, I'll be trying to be into it. So let's think about it in the following way. So we have this game between a policeman and a driver. Okay, so the driver, so this little t, I'm going to explain this. The little t, think of as the type of the driver. So the policeman's going to see certain things about the driver. He's going to see the driver's type. He's going to see is the driver, male, female, white, black, driving a Chevy, driving a Mercedes, whatever. Okay, and he's going to have to make a decision about whether to stop that person or not. And that person, prior to getting on the road, presumably, had to make a decision about whether to be carrying drugs, so working as a salesman, or non-criminal work of some kind. Okay, so the payoffs here, the first number in each box in each element is the driver's payoff. Second number is the policeman's payoff. So to read this, to understand what this is saying, what I'm saying is, if the guy's carrying drugs and the policeman stops him, the policeman gets 10. If the policeman doesn't stop him, he gets 0. So the policeman really wants to stop somebody that's got drugs. Doesn't want to let him go away. And if the guy's doing non-criminal work, if the policeman stops him, the policeman gets 4. If he doesn't stop him, he gets 5. So the policeman doesn't want to stop innocent people. Okay, it's just a waste of their time. It's irritating and frustrating. A waste of his time. Okay. Now, before going on, let me just point out that what I've done is I've assumed that the policeman's payoffs are independent of the type of the driver. There's a T, but that's in terms of the driver's payoffs, not the policeman. So I'm assuming that the policeman doesn't have any particular desire to stop black drivers more than white drivers. Okay. So in this, one question I'm going to ask is what happens if we change it and have it be biased. But what I'm assuming here so far is that the policeman's not biased. His payoffs are independent of the type of the driver. Okay. Now, for the driver, what are we saying? So we're saying that for the driver, if he's carrying drugs, he's hoping he doesn't get stopped. Because if he gets stopped, he gets 0, and if he doesn't get stopped, he gets 10. If he does non-criminal work, he gets a wage of WT, so that's what the W sub T is. If he gets stopped, that costs him 5. Okay, so being stopped is time-consuming, embarrassing, upsetting, costs him. Okay. I'm assuming that the WT is in the range so that this number here is positive and this number is less than 10. I should say the original paper does a much more general thing than this. I'm oversimplifying it greatly just to be able to tell you some things about it. Okay. So don't think it's as bad as what I'm doing. All right. So first observation is there's no pure equilibrium here. So again, if you haven't done game theory, I'll try to be intuitive. So could there be an equilibrium where the driver always carries drugs? Well, even if you haven't done game theory, you know how economists work. They always assume that in equilibrium, everybody knows everything, everybody's brilliant, right? So if there's an equilibrium where the driver carries drugs, it's got to be the policeman knows that. And if the policeman knows the guy is going to carry the drugs, you know, he's got a choice between 10 or 0, he's going to stop the guy, right, to get the 10. But again, in equilibrium, everybody's brilliant. The driver has to know that. But if the driver knows the policeman's going to stop him, I said this is positive, he's going to switch to non-criminal work. So it can't be an equilibrium for them to always carry drugs. Okay. Similarly, could it be an equilibrium for them always to do non-criminal work? Again, the policeman would know this, therefore the policeman would not stop them. I said this thing is less than 10, so if they know the policeman's not going to stop them, they would want to switch to drugs. So it can't be an equilibrium for them never to carry drugs. So it's got to be that there's some probability of each action. Okay? So now we get into the weirdness of mixed strategy equilibria. So if this seems just bizarre, go with the flow. It'll be interesting. I think it's interesting anyway. So what determines the probabilities? What determines how often people do which thing? So what has to happen is if the policeman's going to be choosing randomly, it's got to be that he's indifferent. You never choose by flipping a coin unless you don't care what you do, right? So it's got to be that the policeman is indifferent. So it's got to be that the probability of drugs versus non-criminal work is such that he's indifferent between stopping the driver and not. But now think about that a second. I said that the policeman's payoffs don't depend on the type of the driver. I'm assuming he's not biased. His payoffs don't depend on the type of the driver. And I'm saying that the behavior of the driver has to be such that he's indifferent between stopping the guy and not. That means that it has to be the same behavior for the driver independently of the type. Right? Because the behavior of white motorists is going to make him indifferent. Because his payoffs don't depend on whether the guy's white or not. It's got to be the same behavior by black motorists that makes him different. So we get exactly the statement here that whites and blacks are carrying drugs at the same rate. Okay. Next statement. For the driver, his incentives do depend on his type. Right? So let's assume, as is true in the data, that blacks are making lower wages than whites. So that means that their incentives for non-criminal work are lower. Again, the behavior of the policeman has to be such that they're indifferent. But that's got to mean that they get stopped more, that black motorists get stopped more often. Okay? That's the only way to make it an equilibrium. So, does that say that that's true? No, probably not. One thing that we get though is if you look at if you expand this thing, I won't make you work through it, so just trust me on this. If you think about the case where the police do enjoy stopping some types of people more than others, and think about, okay, in that case, what should we see? The answer turns out to be that that particular type of person would carry drugs less often, but be stopped just as often as some other type with the same wages. Turns out there is a group that satisfies this property in their data, white females. So in other words, if you buy this story, then you would conclude two facts. One, well, both of which are surprising, perhaps. One, that the police are not, do not discriminate between white and black motorists, at least not white and black male motorists, but they enjoy stopping white females. This doesn't prove that that's true, but it gives us a story. It gives us an intriguing interpretation of the data. One way, I didn't put this on the slide, maybe I should have. One way to think about a lot of economic theories is telling stories. It's constructing an internally consistent story about how things might be. It doesn't prove that things are that way, but it gives us a way of thinking about it. And certainly one thing I would think that this does say is we can't conclude from the evidence that, that these guys are showing that the police are biased against black motorists. You would need other evidence to have real confidence in that. Okay, a fifth use of economic theory. So this is what a lot of those papers in economic theory, theoretical economics, excuse me. I got the wrong journal. There is another one called economic theory, and there's theoretical. Anyway, that's not there. Another use of economic theory is developing tools. So a nice example of this, Spence, job market signaling, QJE 1974. So I have to say, the thing that's really depressing about this paper, for me personally, is that this is based on his PhD thesis and won him a Nobel Prize. And let's just say my PhD thesis did not get me a Nobel Prize. I worked with a lot of students, and none of them had their PhD thesis win them a Nobel Prize. Some of you may do a PhD someday, and I hope you're not disappointed, but so if any of you win a Nobel Prize for your PhD thesis, please send me an email, okay? So I'll feel a lot better. Anyway, so what did Spence want to study? He wanted to think about signaling. So he wanted to think about situations where people have private information that other people don't just directly observe, and they want to convince other people about this information. And they want to convince them in a way which is credible. So he focused specifically on job market signaling, as the title of his paper would suggest. So he's thinking about potential workers who are trying to persuade potential employers that they have high ability. So some of you probably know this model, but in a nutshell, what goes on is that he says, well, high ability high ability students find school easier. And therefore they go longer, they get more degrees. They don't take longer to graduate, so that part, so don't misread the going to school longer. But they get more degrees, basically. And so therefore, as a potential employer who understands this, you say, oh, look, that guy, got 27 degrees. He must really be smart, because he just found that so easy to just keep doing that. So that's how it works. Now, Spence assumes in this model that education has no effect on ability. Okay? That whether you go to school for 20 seconds or never or 20 years, you have the same ability. He also assumes that there are no grades, or equivalently, he assumes that everybody gets the same grade, and no academic awards, nothing like that. He assumes that every student, all else equal, prefers less education. So in other words, aside from this, the fact that it may signal something about your ability, the students in his model would rather get no education at all. It's only that signaling effect that they care about. So I should note that Spence did later in life become the dean of a business school. So anyway, enough said about that. So aside from business schools, though, I think it's clear that none of these things are actually true. I hope Spence actually believed that. But the point is that by taking these clearly true things and throwing them away, he's able to focus very clearly on the signaling issue. And he creates this model, which has since been used, he got a Nobel Prize for it because it's been since used to study a huge variety of phenomena and help us understand a lot of different kinds of behavior in terms of, maybe this is happening because of signaling. Another example, which is dear to my heart, Gall and Pessendorfer's Temptation and Self-Control, Econometrica 2001. So let's think about the following question. You see somebody, and you see the choices that they're making, the behavior that they're engaging in. What kinds of choices would lead you to conclude that they did this because of temptation? So let me be clear what I mean by that. So, you know, in economics, normally, most of the time, we assume people have a utility function, they just maximize it. So by temptation, what I mean is a situation where the agent has multiple conflicting objectives. You know, might even call them multiple conflicting utility functions, where there's something that the agent thinks he should do, and something different that is what he wants to do. And where somehow there's some conflict that he manages to either maybe he gives in to the temptation, maybe he finds the way to compromise with the temptation, maybe he just fights it off completely. But that's what I mean by temptation. So what kind of behavior would tell us, hey, this guy is dealing with a temptation issue. This guy is being tempted. So it can't just be something like, you know, he's eating ice cream sundaes, you know, every night for several hours, you know, 3 or 4 of them in a row. That by its, I mean, that would make me wonder. But that can't prove in any way. It can't even, let me be more careful. It could easily be that this guy is just a normal utility maximizer, but he just really likes ice cream sundaes, right? There's no way you could distinguish those two hypotheses based on this observation. Just not possible. All right, I'll ask an even harder question. What behavior would tell us that this person is subject to temptation, but managed to exert self-control? So, you know, we see the guy actually eating healthy dinners night after night. How do we know that that's a result of self-control, as opposed to he just doesn't like ice cream? Well, everybody likes ice cream. Okay. Let's go with that. So that seems really hard, because now we're talking about trying to infer something about what didn't happen, right? That he didn't give in. So they have this great answer, which is they say, let's think about the choice of menus or restaurants. Okay, so let's suppose we have somebody who's faced with a choice between 2 restaurants. Okay, and restaurant A is, you know, nice place. And think of all the meals in all these restaurants as being exactly the same price, so we don't have to think about price issues. Okay. So restaurant A has all these healthy dishes and nothing fattening at all. Okay. Restaurant B has an identical menu, but then has another page where they have, you know, hot fudge sundaes and pick your favorite thing, stick it on there. Okay. Favorite unhealthy thing. Okay. So economic theory, you know, being a little facetious here, economic theory would seem to say, what you would have studied in certainly in principles or intermediate micro, you would have been told bigger choice sets are always better, right? A bigger budget constraint, that's got to make you better off, right? To have more choices, how could you be worse off? But suppose this guy says, no, I want to go to restaurant A. If he chooses restaurant A, it's natural to say that the reason that he wants the smaller choice set is he's worried about having those tempting options. Okay, that's what's revealed. That could be interpreted as him being worried about temptation. Now let's take it another step. Suppose he says, no, I really want to go to restaurant A, the one with just healthy stuff. He goes to restaurant A and it's closed. And he says, damn. And he goes to restaurant B. But when he gets to restaurant B, he doesn't eat the unhealthy stuff. He eats the healthy stuff. He eats something he could have had at restaurant A. Okay. A natural interpretation of this is that he exerted self-control. Right? He was, for some reason, trying to avoid having this option. Let me be careful. He was somehow not wanting to go to restaurant B. Was unhappy, was disappointed that he couldn't get into restaurant A. And yet he did something he could have done in restaurant A. Okay? He didn't pick one of the things that he presumably was worried about. So that suggests that a natural interpretation of that is he exerted self-control, But it was costly. Why costly? Because he didn't want to go there to do this. Right? He really wanted to go to the other restaurant. So, again, we can't know that this causes the behavior. We can't say, aha, the theory proves that this guy did this for this reason. But again, it makes a nice story. It makes a natural interpretation. So they, based on these ideas, they give this very nice model where they think of people as picking to maximize their utility minus a self-control cost. And this self-control cost depends on the menu, depends on the other choices available. That in restaurant A, where there's nothing but healthy dishes, you're not tempted by anything, you can pick anything you want and it doesn't cost you anything in terms of self-control. Restaurant B, you go in there and there's broccoli and there's hot fudge sundaes. And to pick the broccoli is hard. Right? It really costs you something. Got to make it tofu and then I'm in trouble. But anyway, final comment. So these are tools we're developing. These are tools we're developing in the hopes that we'll be able to use them for things. The signaling model of Spence, I think we've used for a lot of things. The temptation model of Gull and Pessendorfer we started to use for more things. And the hope is that we'll understand things better. I think if you compare economics now to economics 50 years ago, I think it's fair to say that we actually do understand some things better than the economists 50 years ago. And it's certainly not because we're any smarter than the economists 50 years ago. The fact is we have the insights of the economists of the last 50 years to build on. And I conjecture, I don't think I'll be around to verify this conjecture, but I conjecture that 50 years from now, what we're doing now will look very primitive. Maybe like that. So this is early microscope. And that's all I got. So thank you.
That was a fantastic talk, and I would like to now open the floor to questions. So if any of you guys have some questions about what Professor Lipman actually explained about the models, please go on.
Or anything.
Or anything.
NCAA tournament. I would say game theory does not help in the NCAA tournament. So I kept trying to solve this. I kept trying to fill out my brackets by using game theory. I kept trying to do backward induction. Start at the end, when the tournament is over, and then see what the outcome was. It just didn't work. Yes.
So I'll ask a stupid question to get started. Always kind of debate between whether economics is a science or like an art. And since you're kind of like theoretical, sort of like, based on a lot of things, but where do you kind of come down on that? Like, do you think that like economics in the future should be more math-based, or do you feel like it should tend more towards society or like social-based?
Well, first, in terms of art or science, I'm tempted to say cult, but I think I think the answer is God, now I'm going to quote Sarah Palin. All of the above, in the sense that I think economics does have to get more mathematical because I think we deal with a lot of complicated stuff, and and I really believe the only way to understand something complicated is with a very precise language for discussing it, and that means math. So I think that's true, but at the same time, I don't think that means that we don't pay attention to what psychologists have to say, or even, God forbid, sociologists. That we should ignore, soft data in that sense. So I don't see it as an either or. Yeah.
I've seen, looking at Gary Becker's paper on marriage, for example, and even your working paper on how language was founded, I think, if I'm getting the title right. Where do you think, you think economics especially can be applied using mathematics to nearly every single phenomena? Where does it draw the line? Because I always thought language was something that could be stuck to language.
You can find different opinions in the profession on that. My own opinion is the definition of economics is what economists are interested in. I'm employed in the economics department, and I wrote on language, and therefore language is part of economics. A little less facetiously, I think I don't think one has to say marriage or language or something like that is part of economics. I think, we have a lot of tools and we can use them to talk about a lot of things that we find interesting. And if you want to say, okay, when I'm writing one language, I'm really moving out of economics and doing something in linguistics, that's fine, I don't care. As long as I don't get fired for it. That's, yes?
So you're saying that economics should get more mathematical and it's going to proceed in the next 50 years, but when you're dealing with humans, what's the line that you can go up to where you can use math to explain people's preferences? I mean, you compare 30 axioms just to clear one preference that a human will do, but isn't it going to get too complicated when you're dealing with people?
So that's a good question. People are complicated. So the question then becomes, how do we deal with that? I'm arguing that the way we have to deal with that is by having mathematical models that are going to focus on the parts of their behavior that we want to focus on and simplify to the point of being unrealistic on the parts that, for that particular moment, we don't want to focus on. And then when we want to say, oh, well, actually now let's switch and talk about that other behavior, then we'll switch where we're simplifying and where we're not simplifying. And I think ultimately that's the only way we can do it. Because if we try to do it without any math at all, then I don't know how I don't know how that's going to help us deal with something extremely complicated. Right? Yeah, you would. Sure.
I'm studying engineering, and in engineering we always say, try to make everything less mathematical, like as less as you can. We always try to make it least mathematical as we can because it gets too complicated when we put too much math into it. And what makes you think that making it more mathematical will make it easier or more useful than less mathematical?
I'm not saying more math is always better. Okay, so one of the things that I often end up telling students and telling other economists when I'm refereeing their papers is, this is too complicated. But I think the answer is things have to be exactly as complicated as they need to be to say something interesting on the topic, and no more complicated. I don't know much about engineering, so I can't really comment on that directly. But I would say, if you're building a bridge, similarly, you want to do exactly the right amount of math. There's no point in making it more complicated than it needs to be. But I think in general things are complicated. So, yeah.
Okay, with your beer model, you mentioned that a lot of, I guess the way that I would have thought that you were going to go through with that was obviously marginal benefit over marginal cost. People stop when marginal benefit equals marginal cost. So that would be like me drinking a beer, and then I'm like, okay, I still feel fine. Drink the next beer. And then after my fourth beer, I start throwing up. I'm like, okay, that's enough. But then obviously there are people who drink 6 or 7 and probably don't care, and those are irrational people compared to an economist, like in the economist point of view, because we always try to develop our theories based off rational people. So I guess what I also think is interesting too is how would an economist deal with people who are not rational or just do things
okay.
like that?
So
yeah.
That's you hit one of my pet topics. I don't believe in the word rational. I try to avoid using it because I think economics has come around to the point where, so for example, I talked about the Skull and Pesendorfer thing, and I said, people are tempted, and they have these, they maximize utility minus cost of self-control, and is that rational? I don't know. They're tempted. A lot of people would have said, oh no, temptation. That's how could you be rational when you're tempted? It doesn't even make sense. But it's utility maximization. So I'm really uneasy about the word rational because I don't know exactly what it means. Economists often use it to mean that people have some kind of preference and are acting in a way that's in accordance with that. And if that's what they mean, then I think it's tautological that people are rational. If I really have a preference, then how could I have a preference and not act in accordance with it in some sense? It doesn't even make sense. So in terms of So I would rephrase your question then as, can I use economics and these tools like utility to talk about behavior, which is in some sense, let's say, foolish? And I think the answer is yes. I think this model of temptation I was talking about is exactly that kind of model. So absolutely, yeah.
In some models, especially like in macro models, when people build a macro model, they try to be insightful, basically. But empirically, the models actually don't fit with the data. So is it a good philosophy to do both? Because I think to predict the future, you better do something strategic than doing something that's more insightful. That thing should be separately.
No, that's a good question. First of all, I should say I'm not a macroeconomist, so I'm not sure what I say would be something that the macroeconomists would necessarily agree with. But I would say that there is a trade-off between, which I think is captured in that Coase quote that I gave you. There's a trade-off between prediction and understanding. If I really want to predict well, maybe a purely statistical model with no economics in it whatsoever is going to end up getting better answers. It's not clear. But if I really want to understand what I'm talking about, and I want to be able to say, well, if the world changes in this way, what's going to happen? This purely statistical model is not going to help me. So my interpretation of what I see in macro is that it's very similar to the kinds of things I was saying, that they're not really surprised that the model doesn't fit the data perfectly because they didn't expect it to. It's a model. It's a theory. It's not truth. But what they're trying to do is to find ways to capture the ideas and the intuition, but still get something in the direction of prediction. So they're trying to sort of explore that frontier, if you will, between understanding and prediction. Yeah.
How do you go about tackling like non-quantifiable variables when you're doing a model? Like, something that you really never can measure. So, but you still have to use it for the model to make sense. So how do you approach that? Did you pretend it's real, or?
That's tough. That's hard to answer. Excuse me. That's hard to answer in the abstract. I mean, in general, I would say that what one has to do is to come up with. One has to be clever, which is easy to say and hard to do. I mean, for example, I would take this Cullen-Pheasendorfer thing. When I first talked about temptation, that seems really amorphous, and how would you quantify it? And what does it mean to be more tempted? I mean, it seems very. I don't know if it fits exactly what you had in mind, but it seems in the direction of the kinds of things you're talking about that seem non-quantifiable, and yet, by some very clever thinking about it, they make progress. They get a model which has something that can be interpreted as temptation in it. So, I think that's where research gets really hard and really interesting, is finding ways to deal with that.
So I suppose the follow-up question is, so are you just looking for the relationship between the variables? Like, and that's what's really important, is that you can prove the relationship between variables, and then you can kind of prove the concept?
I would say that's part of it, but I would say part of it also is something I didn't really emphasize is the story that I want to, one of the things that I like about this Cullen-Pheasendorfer thing is, they're going through a bunch of math and so on, but there's a story there that I can think about that helps me reason about this kind of behavior. So it's not just, variable A and variable B end up getting the right, relationship in the comparative statics. It's more than that. But that notion of sort of the model tells a story that makes sense and resonates and helps me think. Again, very hard to make precise what that means, but you know it when you see it. There's another question.
So everyone, we'll go with just one final question, I guess, and we can, and then if you guys want to ask Professor Lipman after that, please, if he's willing to take questions after that on a more personal basis, please go on after that.
There was a question, yeah.
So I just had a question about how you perceive perhaps the economics as a branch of knowledge will sort of progress. in terms of, I've noticed that economics, at least as an empirical study, has become part of a lot of other studies. So for example, business, public policy, international relations.
I'm
all-
tempted to say they become part of economics, but that's,
Well-
they become intermingled.
That as well. So do you feel that economics sort of as a discipline is heading in a theoretical direction while the empirical branches are sort of spreading out among other disciplines? Just something I've noticed recently.
I think it's true that economists understand economic theory better than people outside of economics, and so there's probably something to the argument that the empirical work is spread a little more broadly than the theoretical work. I don't see any reason to think that's going to always be true. I don't have a strong opinion. That was short. Going to do another one?
Much like you take issue with, like you said, the word rational, I take issue with the term reality and what some might distinguish as disreality or unreality. What are your thoughts on distinguishing between the two?
Between which two? Between reality and
Well, how you
unreality?
define reality and how you define that which doesn't fall under the definition. It's a little abstract.
We're getting very philosophical.
Yeah.
I like just saying reality is overrated because I find it very amusing. But what all I mean by that is, well, it's the kind of thing that I was talking about. That I'm perfectly happy to think about models that I know are counter to reality, are counter to the facts in the world that we can clearly see.
Mhm.
Because again, I think you have to ignore some things in order to make any headway in understanding other things. I don't know if I answered your question.
Well, anyways, guys, please can we have another round of applause for Professor one last thing before you go. Using our keen optimization models, we discovered that Professor Lipman actually has a high utility preference for chocolate cupcakes than vanilla. So we actually went out and got him one, just to thank him for actually coming to this event. We noticed he teaches grad classes and PhD classes, so to actually come and speak to us is a treat. So please accept this from us as a token of our appreciation.
Well, thank you. Thank you. Thanks very much. And it's the right place.
See you all.
Thank you.
Thank you for coming.